Figure Robotics announces one of their biggest breakthroughs yet, a vision language action VLA model for generalist humanoid control. So we've talked about the vision language action models before. We've seen Google DeepMind put out a great blog post and a kind of explanation of how it works. So at this point, most people know what a large language model is, LLM, right? So like ChatGPT, it's able to talk to you back and forth. If we add a vision capability to it, it's sort of a vision language model. So it's able to look at things, answer questions about it, etc. And the action part, here's a great explanation from Google DeepMind, right? So if you have a VLM, a vision language model, right, you can take images as input, produce a sequence of tokens that represent natural language text. So in this image, if you ask it, how would you push the ketchup to the blue tube? It could, like, in a language and words, describe to you how it would do it, but translating that to actual robotic movements is the next step. That's the A part in the VLA. So the action part is translating those sort of text, thoughts, etc., to actual robotic commands. This sort of model and robot is a series of firsts. HELIX is the first VLA to output high-rate, continuous control of the entire humanoid upper body, wrist, torso, head, and individual fingers. As we'll see in a second here with the demonstration, it's quite agile. It's quite adept at moving things around. But this is really interesting. So they're saying that HELIX is the first VLA to operate simultaneously on two robots, enabling them to solve a shared long-horizon manipulation task with items that they have never seen before. We'll see a demonstration of that in just a second. And Figure robots equipped with HELIX can now pick up virtually any small household object, including thousands of items they have never encountered before, simply by following natural language prompts. And it's one neural network. Unlike prior approaches, HELIX uses a single set of neural network weights to learn all behaviors, picking and placing items using drawers and refrigerators and cross-robot interaction without any task-specific fine-tuning. Commercial-ready, HELIX is the first VLA that runs entirely on board embedded low-power consumption GPUs, making it immediately ready for commercial deployment. We have a number of robotic companies that are showing incredibly fast progress and innovation. We have Figure, we have Optimus, we have Unitree, right? So those are that already have like robots that are they're able to demonstrate their work kind of in the real world. Maybe they're not sort of a full scale production, but we're actually able to look at them and see the things that they're able to do in sort of a real life. And just like the large language models, just like the AI progress, it really seems like this also will be very sort of democratic. It will be not just one company that has a monopoly on AI or a monopoly on robots. We might see these things be very widely available, a lot of competition, driving innovation, bringing the prices down, etc. I think 2025 will be the year of the robot. Take a look at this little demo video that they did, and keep in mind that the robots that you see are controlled by one sort of brain, one model. So similar how you would use two hands to do something, these two robots, think of them as two hands on one individual, working together to achieve a task.
Hey, Figures, can you come here? Okay, I'd like to try something new. Even though this is the very first time that you've ever seen these items, I'd like you to use your new HELIX AI and try to reason through where you think they belong in the scene, and then work together to put them away. Does that sound good?
So absolutely fascinating. So again, the blog post describes these robots as being sort of controlled by one sort of brain, so one model. So this might be probably confusing to some people. So they're saying one neural network. So by which they mean, like, it's not like there's a different neural networks for different skills. Like there isn't one for recognizing objects and one for, how to pick up objects and one for talking or whatever. It's all sort of one neural network that's taught all the different behaviors. So what's interesting here is you see the robot on the left complete a task and come back to the starting position. But notice what happens next. So the robot on the left that's not doing anything kind of puts its hand out, and notice it's putting its hand out and it opens its palm upwards, ready to take something. It's hard to tell because they cut away from it. And this is one thing that I've complained about before with Figure, and other people have as well. They make very beautiful, very stylized clips of these robots. A lot of people are like, dude, just give us like a phone camera, like a live stream. Just don't cut it. Like, just if it's an hour long, that's fine. Just let us see it without any camera, movement and stuff like that, just to see what's happening. But as far as I can tell, both of those at the exact same time begin the movement. One is reaching towards the cookies, one is putting its hand out, and the hand just stays there until it's given the cookies. It also seems like it happens here, where one robot gives, as you can see, the other guy already has his hand out. But it's kind of hard to gauge because they cut the camera angles quite a bit. And in both scenarios, what's interesting is after the handoff, they kind of briefly like glance at each other, which I think they probably added as almost like a social thing, because you'll notice they do the same thing when the guy walks up. They hear him, so they both kind of look at him. So I'm sure the turning the face towards the person or the thing that you're working with, that might be something that they've added as an instruction. So notice here, so they hand off the, what is that, sliced ham of some sort, and they briefly glance at each other before resuming the work. Right here it happens again. So they hand off the cookies, and I think directly after they glanced at each other very briefly. Yeah, you see how they like look at each other like, all right, we got the cookies, let's continue. And of course, same thing here in the beginning, the human starts speaking and they both glance at him to kind of confirm that they're looking. One thing that I'm slightly confused about is they're saying that HELIX is the first VLA that runs entirely on board, right? So embedded low power consumption GPUs make it immediately ready for commercial deployment, right? But the model also operates simultaneously on both robots. So I'd be curious to know more details about that, like, right? Because if it's controlling multiple robots, I would kind of think of it as like one central server or whatever that then the robots are connected to, that then sends the commands for them to execute whatever. Here they're saying that it's entirely on board. So I'll try to see if I can get some answers on that, and I'll post them in the comment section below or on Twitter if we get that answer. One of the things that I was a little bit disappointed early on in Figure development was that they said it seemed like they were focusing mostly on commercial tasks. So warehouses, factories, etc. I was kind of hoping to see this for in-home use, and high quality data was one of the limitations. So this is something that's very exciting. So first of all, they're kind of saying how the home represents a robotics greatest challenge. Unlike controlled industrial settings, home aren't filled with just a bunch of random crap, right? Again, that's why they decided to first and foremost focus on industrial settings. It's more controlled, it's easier, it's more standardized. The environment inside a home is pure chaos. Maybe that's just me. So for robots to be useful in households, they need to be capable of generating intelligent new behaviors on demand. So basically generalizing, right? So they need to be less robotic, if you will. They need to be able to kind of generalize to all the various objects and locations of those objects that they're going to see around the house. And so the traditional approach of training these robots, it was basically, using a PhD hours to create various ways for robots to become more intelligent. In the past, I believe Figure AI had some job openings for people that would do teleoperations. So basically they would put some sensors on, put one of those visors on, and kind of demonstrate or record some movements of how to do stuff. And that sort of data, the visual and the movements, that data would be used to train robots. And sort of the next step was seen as sort of like the fleet model. We've talked about this like 6 to 12 months ago. So this idea that whoever is the first kind of company to get sort of some critical mass of robots out there in the real world working, those robots, as they go about their business, right, they're collecting data, right? So they have a video of the environment, of them interacting with the environment. And each robot in that fleet contributes to the learning of the entire fleet. And that's not just theory. We've seen, for example, Google DeepMind kind of demonstrate that that is indeed possible. So Google DeepMind published a paper called Auto RT that talks in part about this idea of a fleet of robots going around various like office buildings, collecting data, right? And as they're seeing things and doing things and receiving instructions, whatever, all of that is being collected as training data. And the whole fleet gets sort of upgraded from these individual learnings of each robot. Kind of a cool concept. But this new idea that they're proposing, which is the fleet model. So we are taking the fleet model, we're building on top of it, and we're adding, this thing that they're calling HELIX. And HELIX is able to get these robots to understand new behaviors with no programming or demonstrations, right? So that in theory would allow it to scale much, much faster than the other approaches. So how were they able to sort of make that happen? Well, the idea came from what if we could simply translate sort of a lot of the semantic knowledge captured in the vision language models directly into robot actions, because a LLM or a VLM can explain to you how to do something, right? If there's an apple on the table, how would I take a bite of it, right? It's step by step and whatever sort of layer of complexity that you want, explain to you how to pick up the apple and then bring it to your face and take a bite of it. It can explain it to you in English, but how do we take that and translate that into robotic motion? Well, they built HELIX to bridge this gap. So you've probably heard about System 1 and System 2 thinking, right? So System 1 is kind of our intuition and instinct. I think an AI created this, or somebody misspelled intuition, but that's our intuition and instinct. It's unconscious, it's fast, it's kind of like autopilot. If you're playing a sport, you're not really thinking through each specific action. You're not verbalizing it in your head. You're sort of just reacting quickly on autopilot. It's unconscious and allows you to move very, very fast. And then System 2 is kind of the rational thinking, right? It takes more effort. It's slower. It's illogical, right? It might take you a while to come to the conclusion. So an LLM writing out step by step how to pick up an apple off the table, that's System 2 thinking, right? It's going to take a while. It's slow, right? It takes effort. For robots, we need that System 1. We sort of need to compress that into a subconscious space. The reaction is unconscious or subconscious, however you want to phrase that. Unconscious is probably the more correct word to use here. So System 2 thinking, right? So we have the various robotic images. We have the text commands, right? Pick up the butter and hand it over to the robot on your left. We have the sort of the joint angles, finger positions, right? So the robotic movements. And this is running on the 7 billion parameter pre-trained VLM, vision language model, that runs on the onboard GPUs. And the System 1, that's more like the unconscious reaction, right? Somebody flicks their fingers near your eyes, you blink. It's an unconscious reaction. It's fast. It's reactive. Interestingly, that runs on a different GPU. And here they're mentioning that the VLM, so kind of that System 2 thinking, right? It's an open source, open weight for System 2, a simple transformer-based visual-motor policy for the System 1. So recently, we've of course heard about the split of OpenAI and Figure AI. For a while there, it seemed like Figure is going to be running on OpenAI's, large language models, vision language models. Now it seems like there might have been some sort of a split, and OpenAI is hiring their own robotic researchers, and it seems like Figure AI went with this open source, open weight VLM. What's interesting here is the data that they've used to train these robots, because remember, it's supposed to be generalized very well between objects, right? So whatever weird toys or things you have in your house, whatever knickknacks and decorations or utensils or plates or dishes or whatever you have, right? They're all going to be slightly different from house to house. So it needs to generalize very well. Not each plate is going to be identical. Not each chair is going to look identical. And this is kind of the fascinating part about how quickly AI is progressing is not that long ago, maybe 6, 12, 18 months ago, something like that, everybody was convinced that we might be coming to an end of some of these scaling laws because we're going to be running out of data, right? So we're sort of we've trained these models and all the data that there was, and now we're sort of at the end of it, that's going to be a major bottleneck. Certainly we've heard something similar said by some of the people at Figure AI, I believe, it's going to be hard to get enough data to train these robots to perform tasks inside of people's homes because of how much variety there is. So this is Jonathan Ross. So he's ex-Google. He worked on the tensor processing unit, the TPU at Google. And he is now the CEO and founder of Grok, right? That language processing chip. So he's saying he's the creator of the TPU and LPU, right? So TPU is Google, LPU is Grok, his company. And so he posted this that a lot of people are sort of slowly beginning to realize, we've been talking about it, we've been seeing it more and more. But still, not that long ago, there's people kind of not getting this, not grokking this, if you will, right? So he's saying this, there's something about the LLM scaling laws that people don't realize. And by the way, he's talking about LLMs, but this also really, really does apply to a lot of the other AI models. This also is going to apply to robotics as well. So really, this is for neural nets in general. So he's saying when someone says we've reached the end of the scaling laws, they usually mean that we've trained AI models on all of the data on the internet, right? So we've reached sort of the end of the internet. They think there's nothing left to train on. So logically, the models can't continue improving at the same pace. But here's the thing, the conclusion assumes the quality of the data is uniform. It's the same. In reality, if the data quality gets better, the model can keep getting better. So he worked at Google. He witnessed this in action at Google. So the AlphaGo team developed an AI model that beat the world champion in Go. So Lisa Dole, Move 37, right? So already it's better than humans, right? Better than human champions. And that model was trained on existing games. So on human data, humans played the games. So we've kind of recorded those games and we taught the model, AlphaGo, to play Go based on those games. And that was great, but not the point. The point was later they built a new version called AlphaGo Zero. And by the way, the DeepSeek model, one of them was called the R10. So zero here means or refers to, I think, kind of the same idea of we're not using human data as much or at all. So AlphaGo Zero didn't use any existing games at all. Instead, it trained by playing against itself, right? It was even better. So we sometimes refer to that as synthetic data, right? It creates synthetic data, and these models can get better by sort of training on that synthetic data. Oh, and by the way, AlphaGo Zero was much, much better. We've seen the same thing with the chess AIs, and we've seen some very interesting things with R10. So we're seeing this like over and over and over again. So how do you improve a model by having it play itself? Well, you start by having it play itself, and when it makes a good move, add that to the training data, right? That's synthetic data, right? Then you train on the better moves to make the model better, repeat. And that's how with synthetic data and RL, reinforcement learning, you can escape the limits of the scaling laws. Now, coming back to Figure AI and how they acquired their data, it's similar. This isn't a self-play where it kind of creates the data by playing against itself. This is a little bit different, but it started by collecting a high-quality multi-robot, multi-operator data set of diverse teleoperated behaviors. 500 hours in total. Not that much, really. To generate natural language conditioned training pairs. So training pairs is, for example, like if you're training a model to, recognize images, you might have an image of a dog and a label called, dog, right? So if we ask it what a dog looks like, it's able to figure it out. So a training pair is like, this is this. Picture of a dog, the word dog. Picture of a cat, the word cat. So here, the sort of training pairs are these like teleoperated behaviors alongside with, we want the natural language descriptions of it. Like here's a person picking up an apple. How they create those is they used an auto-labeling VLM to generate hindsight instructions. So the VLM processes segmented video clips from the onboard robot cameras, prompted with what instructions would you have given the robot to get the action seen in this video. It's like an AI movie critic that sits there just watching videos and then just like writing comments about it. And so here they describe a little bit better what I think they meant by this idea that this VLA, that one model is controlling sort of both robots. So they're saying that both robots operate using identical HELIX model weights, eliminating the need for robot-specific training or explicit role assignments. They achieve coordination through natural language prompts like hand the bag of cookies to the robot on your right, or receive the bag of cookies from the robot on your left and place it in the open drawer. This marks the first demonstration of flexible, extended collaborative manipulation between multiple robots using a VLA, particularly significant given their success handling of completely novel objects. Okay, so this part makes more sense. So when they're saying it's the first model to operate simultaneously on two robots, enabling them to solve a shared task, they mean that it's two copies of the model. So each robot has a copy of the model. It's the same model, same weights, but the model is able to sort of coordinate how that happens. And what this allows us to do is to pick up anything. So basically it doesn't have to be pre-trained on specific things. It can kind of figure it out. Pick up the kid's shoe, the gold cassette tape, the alarm clock, the leopard print shoe, etc. So pretty exciting progress. Let me know what you guys think about this company. I would love to see some unedited footage, some, very informal settings, just somebody with a cell phone camera, unedited, at length, and actual kind of use cases, and kind of like to see what these robots can actually do, like kind of like real world. They have a contract with BMW, so it sounds like they deployed them to work at the BMW factories. Here's that video for that. But, in the video, they say this is Figure HQ, right? So this is like an environment where they set up the robots at the Figure HQ. And I mean, when they play the video, certainly this looks very, very cool, very advanced. But I mean, how real is this? Like, I would love to be able to see how they got these things to do it. Was it voice commands? Was it demonstrations? Like, what are we looking at here? I'd love to know a little bit more about that. A year ago, they had this demonstration here that was pretty cool, where the robot was activated with a voice command to make a cup of coffee, but the researcher was the one that actually placed the coffee mug into the coffee machine, right? Then told it to, make a cup of coffee. So it is able to pick up a tiny object and place it into the machine and then close that machine. Although closing it is fairly simple, since you don't even need 5 digits for that. You just push it down and it closes. And some people online were kind of like talking about that this isn't maybe the best demonstration of it. So I guess what I'm saying is it would be incredible to see more unedited raw footage of people like interacting with these things, what they can actually do. I mean, the videos look incredible, right? They're highly polished, great lighting, great sort of aesthetics, right? The robots are very shiny. But I think what a lot of people are asking is like, give me like the dirty, gritty, real world sort of use cases. What are they doing? Often we see these robots, they're already in position when the demonstration starts, right? So everything's kind of set up where if you notice, they take a step forward. Here in the beginning, they take a step forward, 2 or 3 steps forward to kind of get into position. But then throughout this whole thing, like everything's sort of arranged so that they really don't have to move that much. So it's sort of just like pivoting the torso, but they don't even have to take one step in order to complete all of their tasks, right? In this video here, the robot receives a voice command and he's able to do some stuff with the objects in front of them, but no walking around, no movement. In the BMW update, so there's a lot of walking and movement, but there's no voice command. So we're not really sure, like, how did they get these things to do it? And also, how did they get them to like synchronize it so well? I mean, look at that. They're like in perfect kind of sync, maybe like a split second apart, doing those sort of like the exact same motion, right? Meanwhile, the Unitree is like out there, like getting beat up, but we're seeing it walking. I mean, we're seeing it tripping and falling and messing up, but that's okay, because we're able to sort of like get a realistic idea of how it moves around. I mean, the developers, the people that are building it, they're not shy about beating the crap out of these things, and we're able to see how they perform. I mean, this thing just gets like thrown around and like bounces back up, gets back to walking. I mean, it's crazy, but I mean, this is the sort of stuff that I want to see a little bit more of. Here's footage, for example, of Tesla's Optimus robot walking out there kind of in the real world. I mean, he kind of trips a little bit, slips a little bit, but is able to kind of gain its footing. And I mean, just kind of looking at that, so I'm able to see how good it is or how bad it is. I mean, it's not perfect, but you can sort of see that it's like a real robot that's walking and tripping and having issues and stuff like that. Here's footage of Google DeepMind's RT robot rolling around. I think this is actually at the Googleplex, kind of in the kitchens, where it's able to like retrieve some stuff and avoid people, get chips and stuff like that. But I mean, see how the human is like smacking the thing out of its hand in order to see if it's able to bounce back and still continue the task. And here's the Boston Dynamics. Apparently, I mean, it's described as the Boston Dynamics dog meets an actual dog. But as you can see, I mean, there are sort of camera phone footage of that robot moving around and doing stuff kind of in the real world. On the BMWgroup.com page, they do talk about their trial of using these robots at one of the facilities for, manufacturing BMW cars. They're saying this video shows the trial run in the body shop at the BMW Group plant, Spartanburg. So this, as far as I can tell, is that video that they're referring to. So as you can see, the robot in the background carrying the plates, one robot walking, there's another robot walking there in the background, and they're taking sheets from here and placing it onto this thing right there. And here's another shot. So this is from the production line in the plant. So again, it's picking up that sheet of metal and it's placing it onto where it's supposed to go. But again, it's super hard to tell, other than those like 1 or 2 motions, like how did they teach it to do it? Was that with voice commands? How much more stuff can it do? So I definitely would love to see more. So definitely exciting, but I do want to see more stuff like the stuff that's coming out of China where they're just like sprinting, across the park, going up the stairs and stuff like that, getting kind of kicked around. I mean, because that really, I think it just demonstrates the sort of the agility and like the abilities of these robots. And as I'm wrapping up this video, 1X, the other sort of robotic company, is promising to reveal something new tomorrow. So definitely excited to see what they're revealing. And certainly would love to see a lot more sort of just like raw unedited footage out of Figure AI, just kind of like seeing these robots move around and, like in like a real world environment, so we can kind of get a feel for what they're capable of. Because right now we have like really cool sort of looking videos, but it's really hard to tell what's what, if that makes sense. Let me know what you think. If you made this far, thank you so much for watching. My name is Wes Roth, and I'll see you next time.